Today's lesson is about parametric equations. Suppose from an airplane which is 40 meters high from the ground, you hit a golf ball, and here's the trace of that golf ball. From the graph, we know that vertical distance is a function of time, and also horizontal distance is a function of time. The function between vertical distance and time will be this graph. And the horizontal distance and the time will be linear function like this one. When x is a function of time and y is a function of time, we call these equations are parametric equations. The function y equals f of x, we call this is a rectangular equation. Here's the definition for parametric equations. When Cartesian coordinates are represented as a function of the same variable, normally we use t. They are called the parametric equations. So we can write down this way. And y equals f of x, we call this is a rectangular equation. Example 1. Write x equals t squared minus 5 and y equals 4t in rectangular form. First of all, you need to get rid of variable t. So we write down x equals t squared minus 5. Y equals 4t. It's easier we change second equation into y over 4 equals t. Then I plug this one into this equation. So we got x equals y squared over 16 minus 5. This is the rectangular form. We know that this is the parabola equation. Example 2. Write x equals 1 over square root of t and y equals t plus 1 over t in rectangular form. Then graph the equation. State any restriction on the domain. First of all, we write down x equals 1 over square root of t, and y equals t plus 1 over t. So we look at the first equation. This is the second one. We can square both sides. We got x squared equals 1 over t. Do cross multiply. We will get t equals 1 over x squared. Then now we plug t equals x squared into this equation. We got the y equals 1 over x squared plus 1. Then over 1 over x squared. So we multiply by x squared top and bottom. We got 1 plus x squared over 1. which means y equals x squared plus 1. Since we're looking for restriction on domain, so we need to get the range for this equation. We know the range for 1 over square root of t is x greater than 0. So we write down x greater than 0. That will be the domain of this function. Now let's sketch the graph. We use this table. X, here's y. 0, this is 1. 1, here's 2. 2, here's 5. So we plot these 3 points. We got 0, 1, 1, 2, 2, 5. Okay, then I sketch this graph. But since x greater than 0, x cannot be 0. Therefore, we put an open circle over here. Now let's go to example 3. Rectangular form with theta as a parameter. So when we have a trig function, remember we got to use sine squared theta plus cosine squared theta equals 1. We use this a lot. So for x equals 2 cosine theta, y equals 4 sine theta, you will change the first one into x over 2 equals cosine theta. And second equation, we write down y over 4 equals sine theta. Then square both sides. You will get x squared over 4 equals cosine squared theta. And second equation, we can get the y squared over 16 equals sine squared theta. Then we add together. We got x squared over 4 plus y squared over 16 equals 1. Basically, this is a ellipse equation. Let's go to example 4. Find the rectangular form with theta as a parameter. When you have theta as a parameter, remember that try to use trig identities. We know that secant squared theta minus tangent squared theta equals 1. Therefore, you have to square both sides. We got x squared equals 16 secant squared theta. And also we got y squared equals 4 tangent squared theta. So we divided by 16 both sides for this equation. We got x squared over 16 equals secant squared theta. Then we divided by 4 both sides. We got tangent squared theta equals y squared over 4. Then we do subtraction for these two equations. We got x squared over 16 minus y squared over 4 equals 1. This will be hyperbola equation. Let's go to example 5. Use each parameter to determine the parametric equations that can represent x equals 6 minus y squared. Let's go to 5a. T equals x plus 1. Therefore, I can make x equals t minus 1. We label this as the first equation. And we know that x equals 6 minus y squared. Let's label this second equation. So we plug 1 into second equation. We got t minus 1 equals 6 minus y squared. Therefore, y squared equals 7 minus t. Since y greater than 0, so I can write down y equals square root 7 minus t. In other words, the parametric equation will be x equals t minus 1 and y equals square root 7 minus t. Let's go to 5c. T equals 4 minus 2x. Still, we need to figure out the x first. You will get the 4 minus t over 2. Then you need to still plug this one into rectangular form. We got 4 minus t over 2 equals 6 minus y squared. Simplify, we got 2 minus t over 2 equals 6 minus y squared. So we got y squared equals 4 plus t over 2. We do square root both sides. We got y equals square root 4 plus t over 2. Therefore, I will write down x equals 4 minus t over 2. Or you can write down 2 minus t over 2. And y equals square root 4 plus t over 2. This will be the parametric form to this equation. Parametric equation is applied a lot in physics. For example, for an object launched at an angle theta with the horizontal at an initial velocity v0, g is gravity and t is time. h0 is initial height. So we got a horizontal distance will be this one. And a vertical position you will get like this. This is the formula. Let's do example 6. A golf ball with an initial velocity of 56 meters per second at an angle that's 12 degrees down a flat driving range. How far away will the golf ball land? From the given information, we know original speed that will be 56 meters per second. And theta equals 12 degrees. Let's look at this graph. And at this point, suppose this is the highest point. And we know that vertical speed for golf ball, it will be 0. In other words, let's do V they. It will be 0. Therefore, we set up V they equals V0 sine theta. That means the original vertical speed, then minus gt. In this way, we can figure out this t. T equals V0 sine theta over g. Then how far away will the golf ball land supposed to be d? It will be equals 2 times t, then times original speed times cosine theta. That's how you figure out this d. Therefore, we plug in, you will get 2 times V0 sine theta over g. Then V0 times cosine theta. Now I plug in, I got the 2 times 56 squared times sine 12 degree times cosine 12 degree. Then divided by g, we use 9.8 this time. So we put it into calculator, we will get 130 meters will be the solution.